6 friends share 5 cookies equally, how much will each friend get? Hey man, I noticed the answer you have written doesn't match the expression or equation that you have written out. Can you think that through? Start coming to a stopping point, whether you are finished or not. Not a huge deal. Looking for markers to be set down. Less than half the group is finished, so don't feel stressed. If you're like, oh, I didn't finish, it's totally cool. This is a challenging problem, right? I saw you guys set up some really great drawings to represent this problem. Where some people got confused was in writing out the expression and choosing an operation. But I saw lots of people solve this problem with no operation at all. Wait. What did I say?
No operation.
No operation at all, just based on the picture. Let me show you Mila's picture. Whisper to a neighbor. How did Mila represent the 5 friends? Wait, is it 6 friends or 5 friends? I can't remember. I better write it down. 6 friends. Whisper to a neighbor. How did Mila represent the 6 friends? And the 5 cookies. All right, thank you. Joe, where are the 6 friends? I'm sorry, Ben's talking. Go ahead.
There are the 6 squares at the top.
Friend 1, friend 2, friend 3, friend 4, 5, and 6. I saw a couple people put like smiley faces in there to help them remember those are the people. Okay, 6 friends. And the 5 cookies are? What is Mila doing to help her get to this answer? What do you see Mila doing here to get to the answer? Emery?
It looks like most of you use 6.
She split each cookie into 6. How does that help Mila get to the answer? How does that help Mila get to the answer? Calvin?
So like each friend can get 1 6.
Each friend, and she circled, went all the way through and she circled 1 out of each cookie, 1/6. And you can see she gave that with her arrows. Everybody got 1 of them. So how much altogether is that friend getting?
5, 6, 7.
1, 6, 2, 6, 3, 6, 4, 6, 5, 6. That's the answer. 5, 6 cookies, just like that. Right? She didn't use any operations. She just drew her picture to get 5, 6. If we were going to use an operation, what operation, thank you, Mila, what operation would we use to solve this problem? Malik? We've got 5. Are you sure it's 5 divided by 6? Because I saw some people write 6 divided by 5.
It's 5 divided because there are 5 cookies and you're dividing it among 6 people.
Say that again, Minna, but clearer.
There are 5 cookies, but you're dividing it among 6 people.
You're starting with 5 cookies and you're splitting them up among 6 people. So we're not doing 6 divided by 5. And we learned a special trick, a rule for 5 divided by 6. It's not really a trick, it's more like a way of solving this problem. We called it the Jasmine because Jasmine's the one who invented it. What's the rule here? 5 divided by 6? 5 divided by 6. Remembering that the fraction line is also a division symbol. That this is 5 divided by 6. But you didn't have to do that. You certainly could have just used Mila's strategy and drawn a picture. All right, clear your board. Let's do another problem. I don't know. It's totally random. Let's see. Warren, pick us the next problem. Pick a hard one.
I just saw the 2 numbers.
All right, Tara runs. Here we go.
Oh.
Picture Tara running. Oh, I didn't say act it out, actually, Calvin. Tara runs 1 2/5 miles on Friday and 5/8 miles on, you can solve that problem, on Saturday. Tara runs 1 2/5 miles on Friday and 5/8 miles on Saturday. How many more miles did she run on Saturday?
How many more miles on Friday, right?
On Friday, thank you. How many more miles did she run on Friday than on Saturday? Here it is for you to see. Tara runs 1 2/5 miles on Friday and 5/8 miles on Saturday. How many more miles did she run on Friday than Saturday?
What's that?
If you get finished and you would like to try a challenge problem, you need to let me glance at your answer first. Yes, ma'am, you may try a challenge. Yes, Malik, you may try a challenge. Do not erase your work. If you don't have room, you can use the back of your board. Look at that again, Joe.
Wait, is that 4 and 3
Look at that
ninths?
again. Fourths, 3/4. Elizabeth, you may do the challenge problem, either off to the side or on the back. Don't lose your work.
I'm gonna try it. Oh, goodness.
Look at your equivalent fractions again. Will you write down what you're multiplying by for your numerator and denominator? I think that's where you're running into some problems, Ben. Stop, in other words, stop doing it in your head. So now you need to solve the problem. It says, how many more miles did she run on Friday than Saturday? So think about what operation you're using and set up a problem. Thank you, Mila. You want to do a challenge problem? Yes, Calvin, you want to do a challenge problem? Warren, that's correct. You want to do a challenge problem? That's correct. You want to do the challenge problem?
Here are the choices. Jacob has 2 mistakes. Sam, 3/10 mistake, and we want to know the difference. What's our order of operation? Subtraction. Thank you, Leah. Alright.
I have no idea what the right answer to the challenge problem is, Cal. See, if you, Cal, you and Minna have 2 different answers, so somebody's wrong.
I'm 17-ish.
Okay, Cal, just so you know, Emery's still solving the first problem. Let's try not to be in her space.
Miller, what do we need to do? Subtract.
There you go, Ben. Oh, this one's not going to be times 8, because 8 times 8 is 64. Yep, fix that.
Okay. Common denominator would be 10, right?
Yes, Joe, you may work on the challenge problem.
Are already 10s, so how many 10s would 2 be? 4. Okay, Miller said that this would be 4 10s. So what would be the difference between Jacob's cake and Sam's cake?
All right, markers down in 3,
10s minus 3 10s is
2, finished or not, 1,
EJ,
markers,
11,
go. decide what operation to do for this problem out Tara and her Friday and Saturday run? How did you decide what operation to do? Emery?
I did division.
And how come?
Best science class makes posters about their experiment
I was gonna
to
say
hang in the classroom. Each student completed a quarter of a poster, and the class made 8.
So the story asked me how many more did she run on Friday than Saturday? And that sounded like division to you? Would anyone like to agree or disagree with Emery? Aaron?
Each student made a quarter of a poster.
Okay.
Per student. I'll move it. And then 8 students.
And why divide?
Wait,
Let's think about what it means to divide something. What's the word we always sort of sub in there for divide? Like how do you say it? What?
Split.
Split. So if I'm doing division, I'm splitting something up. What am I splitting up in this problem?
1 and 2/5 and 5.
I don't think I'm splitting anything.
Because you're comparing 1 and 2/5 from 5/8.
I'm just comparing 1 and 2/5 and 5/8. I'm saying, here's Friday, here's Saturday. How many more is this than
Yeah,
that?
you're not like splitting them in half.
I'm not splitting anything up. So it's actually not division, Emery and Aaron. It's not division because I'm not splitting anything up. I'm saying, here's Friday, here's Saturday. How many more are these two? Right? If I were to have, like, on Friday there's 5 and on Saturday there's 6. How many more on Saturday than Friday?
No.
Isn't it 1? Emery, isn't it 1? What operation are we doing?
Subtraction.
Subtraction to figure out how many more, right? Don't let the fractions throw you off, right? It's still just subtraction. I've lost my eraser. Who's got an eraser I can borrow? Thank you, Cal. So I'm not clear with the board because this is actually a really hard subtraction problem. Let's see, what was it? 1 and 2/5
Minus 5/8.
minus 5/8. What denominator did you choose to work with?
40.
So 1 and something 40ths minus something 40th. So 5 times,
8.
so 2 times,
8.
which makes this
16.
8 times,
5.
so 5 times,
5.
which makes this.
25. You can't do
Oh, sure I can.
Yeah, because you take the
Wait, why can't I? Wait, Elizabeth, what?
Well, you can't do it unless you add the 1, 2.
Why not?
Because you can't do 16 minus 25.
But I could do 25 minus 16, can't I?
Yeah, but it's not in that order.
It's not in that order, right?
Not in the correct order.
All right, Amanda is messing with you and making you have to regroup. Ooh. So, what did you do to regroup this work? What did you do to regroup? Count.
I need a 1 plus 40. So 20 plus 16 is 56.
Did everybody make this 56 40ths?
Yeah, I know another way.
Minus 25 40ths? Amanda, what did you do instead?
What I did, I subtracted 25 and 16, and 25 minus 16 is 14.
No, it's
I
not.
mean,
It's 9.
yeah, 9. And then I subtracted 9 from 40 since we have a 1.
So what you're really doing there is getting negative 9. Those, if you do 25 minus 16, you're getting negative 9, right? And that, therefore, you're taking 9 out of the whole to get. Then what do you get? 31 40ths.
Yes.
And kind of simplify this.
No.
You sure?
Yes.
You sure?
31 is a prime number.
In fact, 31 is a prime number. The only way I can divide with 31 is if I divide with 1 or 1.
it'd be 31.
Right. So that is actually the right answer. 30. What's the unit? 31 40ths.
Miles more than
Miles more.
Miles more on Friday than Saturday.
Awesome. I have no idea what the answer to the challenge problem is.
16 through 20th, that's what I know.
16 and 3/20ths.
Yeah.
I'm almost finished. I just have to add 3 pence.
I'm not going to spend our time going over it, but go you. I see lots of arrays, box methods set up there, partial products. Exactly the way you should be solving it. And using the box method, right, to make sure you get all 4 partial products. All right, I think we have time to do one more. Woo! Better be an easy one because we only have like 3 minutes. Here, Ben.
Easy.
A small one.
Okay, this is gonna be easy.
Sweet. Yeah. I think we can manage this one pretty quickly. Let's see, Jace, it's a good name, has, not Jay-Z, 3 and 2 pounds of bananas. 3 and 2/3 pounds of bananas and 4 and 3/4 pounds of peaches.
Wait, what?
Jace has 3 and 2/3 pounds of bananas and 3 and 3/4 pounds of peaches. How many pounds of fruit does he have? Okay, wait. Yeah, I am not okay with, oh, that's easy. We just heard that from 2 people. Why not?
Because some people might not think it's hard.
Right. That's a terrible thing to say to make other people feel bad. Don't say that. How many pounds of fruit does he have? Elizabeth, can you keep your board a little more? I've noticed like 4 different people glancing over at your board to see what you're doing, and we need to make sure everybody's doing their own food. Jace has 3 and 2/3 pounds of bananas and 4 and 3/4 pounds of peaches. How many pounds of fruit does he have? You guys got this. Yeah, we have 2 really challenging problems to start. You got this. Did you clear your challenge problem? I was going to say you could work on that.
Can I do the challenge problem again?
Let's see if you get the same answer.
Yeah.
Way to double check yourself. That's a great idea. I don't think that's the right answer, Warren. Can you look at that again? It's 4 and 3/4, not 3 and 3/4, Jim. Yep, you had all the hard stuff right. That's right.
Hard.
That was
That's what I messed up.
lucid.
You said 3 and 3/4.
Would you like to check your work on this one, or would you like a alternate challenge problem? Look at that again. That's my 1-minute warning.
Okay, I got
No, I just erased that because I thought it was time to. Oh, yay. Is this right?
You're so close.
Did I correct it?
So close, Emery.
Wait,
Did I correct it?
wait, times what? 27? No, that's 27. Okay. This man.
Did I correct it? Correct.
Hey, Aaron, what's 2 times 4? There you
It's already.
go. Look at your whole numbers again. Layla, this says 4 and 3/4, and you wrote 3 and 3/4.
We had a fair mistake.
I can't tell, Warren, you're doing a lot of that in your head, so you're the wrong answer, but you don't have any work to explain how you got the wrong answer. Very nice. You're only off by a little bit, but you've done a nice job, and I can see exactly where your error is. So you've done all the hard stuff right. All right, here we go. We're solving. We're solving.
Wait, I'm almost done with the challenge.
Lots of people are almost done.
Wait, do you think?
Aaron's on the last
Did I
step too.
get
She's like,
it
give me a second, I'm on the last part. Here we go. Are we adding, subtracting, multiplying, or dividing?
I got the answer.
Are we adding, subtracting, multiplying, or dividing? How can you tell? Wait. How can you tell we're adding? How can you tell? Layla.
Because the question. Wait, how many?
He's asking whether we can,
There's in the question they're asking how many fruit in all does it have?
Okay.
It doesn't say.
It doesn't say in all, but
Okay.
you can infer that they mean this bananas and these peaches are going to come together, right? So, I lost my marker. Here it is. So I have 3. What denominator did you use? 12. So that makes this what? 8/12? And then 4 and that 9/12? Gives me 7 and 17/12.
Which is 8 and 4.
Right? So Emery, you got all the way to that part right. Then the hard part then is, what do you do with the 17/12? We say, how many 12s can we get out of 17? 1. And what will be left? 5 12s. Combine that 1 back with my 7, and I have 8 and 5 12s. Aaron, you just forgot to grab the 1
Can
and
we check
combine it
the
with your 7.
challenge problem?
3 plus 4 is 7, not 6.
Check
So you did all the hard stuff right.
the error that I made.
All right, team, clear your boards, and we are switching. Clear your boards. It's time to switch.
The error that I made was really easy to correct because since it was additional, that was the only person I just had to add one.
I got 256.
Oh yeah, thank you. Maybe it's because we're both getting two
Neil,
different,
Anna.
and then like
266,544.
I got 256,000. How many percent we got to the group?
Off by a little bit.
Yeah.